session. Okay? So again, readily predictable naman ang pattern class, no? So if I were to give you 4 factors, kunwari, kayang-kaya nyo naman mahulaan kung ano dapat yung magiging final matrix niya, no? Okay? So, once we have this, pwede na tayong mag-compute ng necessary values natin, no? So this is the quote-unquote manual method, no? But again, I'll show you another method. Ipapakita ko din yung simpler methods like yung line nest method tsaka yung data analysis toolpack method, yung pinakita ko last time. Okay? So let's do an example. Ito. Suppose meron tayong two factors which is age and area. Tapos parang this study wants to know if yung price ba ng isang holiday cottage depends on etong 2 factors na to, yung age and livable area. Okay? And they want to know specifically kung meron ba silang linear relationship with each other. Okay? So dito, this is in terms of kroner ata, no? Nakalimutan ko yung meaning ng DDK, pero I think this is a kroner na na currency. So ito, this is your Y, your response. Ito yung X1 natin, si age. X2 natin is area. Okay? So let's try to compute that. Lipat tayo sa Excel. Okay? Meron ata akong data dito. Let me just copy the data now. Saglit lang klasa. Hanapin ko yung data. Ay, naka-ano din pala. Okay. Sulat ko na lang ulit. Okay, so ang data natin. Sulat ko lang yung screen. Let's do Y. Then X1. X2. Y natin, first Y 745, 36, and 66. And we have 895, 37, and 68. Then we have 442, 47, tsaka 64, 440, 32, and 53, 1598, 1, and 101. Tama ba itong last? Double check ko lang class, no? Okay, tama naman. Age siguro to na. Na-off lang ako sa data, no, kasi age is 1. So I probably, this is probably age of the cottage, no, hindi age nung titira doon sa cottage. Okay. Okay, so na-set up na natin. So let's do the matrix muna, no. So again, ang ano natin is A times B is equal to C. Parang ganyan na matrix. Okay, so let's set up. Ang first matrix na kailangan natin is a 3 by 3 matrix, no? So ilagay lang natin siya dito. So the first value is equal to n. So it's just the count lang natin to. Okay? Tapos next value is equal to summation ng x1. So that's sum of your x1, which is this one. Okay? Tapos ang pwede kong gawin, equals ko na lang dito because they are the same value, no? Okay lang yun. Then I have dito naman is sum of x2 lang. So this one. And again, equals ko lang dito because they are same value. Ito naman, this is intersection ng x1 and x1, no? So that's equal to sum square ng x1 values. Tapos dito, this is intersection ng x1 and x2. Tama? X1 and x2. So this is actually sum product of x1 and x2. Okay, hanggang C6. Okay. And dito, this is also intersection ng x1 and x2. So actually, equal lang siya dito sa value na to. Scroll ako. Okay. And lastly, itong last value natin, this is just sum product. Sum square ng x2 values naman. Tapos, ito ang hinanap natin is B, M1, and M2. Okay? If you multiply and just to illustrate, no, para siyang ganyan. So, Okay? So, parang matrix A, zoom in ko pala. Matrix A, multiply natin with matrix B gives us matrix C, which is yung matrix C natin is just, yung first na value is just sum ng Y. Tama? Summation ng Y. Tapos yung next is sum product. Sum product ng X1 tsaka Y. Tapos yung next is sum product ng X2 and Y. Okay? Meron tayong ganyan. So, we have our unknowns here. Tapos, i-multiply natin. If you multiply this matrix by this matrix, this should give us this matrix. And from the previous na lesson natin, no, we know that if A times B is equal to matrix C, then pwede natin transpose actually C or B is equal to C times the inverse of A. So, ang inverse ng A is A to the -1, no? Pero let me just say A prime, no? Pero technically, itong A prime, it actually means transpose ata or something. Nakalimutan ko na yung linear algebra ko, no? Pero hindi actually ito yung symbol for inverse, no? Pero let's just use this symbol. So, yun. If we multiply C with the inverse of A, then we should get the B, which is this matrix. Okay? So, una, kukunin muna natin yung inverse ng A. So, to get the inverse of A, gagawin natin is, select muna natin to. Then we type in equals M inverse of this array. Okay? And if we press enter, we should get this value now. Okay? Now, if we want to get itong B, to get B, multiply natin itong C with this inverse right here. So, gagawin natin is M mult, that is a matrix multiplication. No? We select the first matrix multiplied by the second matrix. Oops, sorry. Baliktad. Gagawin natin is the inverse muna. M mult nito multiplied by ito. Okay. And we get ito siya. So this is our B. This is M1 and this is M2. So if we were to create the model, we get Y is equal to negative 7.61 plus 19.01 plus minus 281.42. So yun yung ano natin. Final model, no? Linear model. Now let's check if meron nga ba silang linear relationship with each other, no? So we do the ANOVA table muna. And we do regression. Then we have your residuals or just the error, no? Then we do total. Okay? So total is computed much the same way, no? Magiging sum square lang to. Value na to. Values, no? Minus grand total. And again, we are just using ano dito class, no? Yung grand total. Yung response variable lang, no? So we get that value. Diba? Let me double check, no? Kung tama yun, nakukuha kong value. Ay, saan yung Excel ko? Okay, tama naman. You have the total, tapos kunin natin yung error natin, yung sa residuals muna, no? And yung residuals na equation is, balikan natin yung Excel, no? To get the residuals, we need yung SSR natin is just equal to this value, no? Ito. So, ito yung SSR natin. So, sum squared ng yi minus b naught yi minus b1 xi yi. So, kung may second pa tayo, so that's minus b2, m2, or beta 2 summation of x2 yi. Parang ganyan. Okay? So, try natin i-solve. So, let's do error. Balik tayo. So, that's equals sum squared ng y. Ay, sorry. Okay. Sum squared ng y minus beta 1, which is this one, multiplied by sum of y, tapos minus m1, multiplied by sum sum product to, of x1 and y minus ang next natin, m2 multiplied by sum product of y and x2. Okay? And we should get 5,963. Okay? 693. Which is correct naman. Okay? So if we do regression, is just the total minus, sorry. This is equal to total minus yung error natin. Okay? So, hindi ko pala yun na to. Move ko lang. Is source, SS, DF, MS, yung next, FCalc, tapos p-value, and conclusion. Okay? So, DF, the DF for the total is just yung kung ilan yung y natin minus 1. So the total y here is 5 minus 1. Sorry. So that gives us 4. The error is equal to no. Yung regression muna, we have 2 variables. So yung una, yung sa simple linear regression, yung naging DF natin doon was 1. Tapos ngayon, ang DF naman natin for this case is 2, no? Okay? So, kasi meron tayong 2 variables. Okay? Double check ko lang class, no? Okay. So, that's 2. Tapos, if we deduct the total from itong degrees of freedom ng regression, we should have the degrees of freedom for the error. Okay? Tapos MS, as always, magiging SS over DF lang siya. Okay? So, we can drag this down. Now, we can compute for FCalc, which is just MS ng source divided by MSE, which is MS ng error, gives us 16. Tapos, yung p-value natin, if we do f.this.rt, ito, and degrees of freedom 1 is this one. So degrees of freedom 2 will be the degrees of freedom of the error. We should get 0.05609, which is a very close value, no? We can say na kung 5% yung gagamitin nating alpha, then this is not significant, no? Okay? So meaning there is no significant linear relationship between the two variables with the, I don't know. Okay? So this is one way to solve it. Another way is using the line nest method, no? So gagawin natin yung line nest method. So line nest method is just equal. We type in line nest. Tapos type in natin yung first known y's. So this is the y. Then we type in the known x. This is it. Ito siya. So if we are doing multiple na x values, you select it as an array, no? So for example, ito x1, ito automatic i-count na ni Excel as the columns will be the number of factors. So if you have 4 factors kunwari, isa-select nyo lang siya lahat. Okay? So under one argument lang siya dito sa function na to. Okay? So in this case, gagawin natin is B2 to C6 lang. Okay? Tapos constant, are we setting it equal to 0? We're not, no? Kasi we want an intercept. So, ang gawin natin is true, or we just say 1. 1 is true. Again, 1 is true, 0 is false. Tapos dito, do we want additional regression statistics? And let's just say we want them, no? Para may additional data tayo. Okay, so if you press enter, we should get these values. So ito, hindi na to count. Wala lang to, no? Kasi ang nagma-matter lang naman is itong two values na to. Itong columns na to. Kasi if you remember, and para lang makita nyo din, no? If you open this, if you click the line as function, may lalabas na tooltip dito. Tapos ipapakita niya kung anong ibig sabihin ng different values. So you can notice na itong below the yung first two rows, meron kang 6 values, and those 6 values are r squared, yung standard error of the y, itong f calculated, tapos degrees of freedom ng the degrees of freedom of the regression, tapos the SS of the regression, tapos SS ng residual or the error. Okay? Tapos itong sa top two rows, magiging siya yung coefficients of the different na factors starting from the last factor, no? So parang magsa-start siya with mn, tapos mn minus 1, mn minus 2, mn minus 3 hanggang sa dumating ka sa m1, tapos yung last value will be the slope b. Okay? So dito, that's the case, then therefore this is actually your M2, this is M1, and this is your B. Okay, tapos dito, itong sign na to, this is just standard error, no, for the X values. Standard error for X values. Okay, so ito yung standard error for the X values. Tapos this is the standard error for the Y. Itong nandito, no? Standard error for Y. Tapos, this is your R squared. Tapos, this is again the F calc. And dito, this degrees of freedom, DF. Tapos, ito is SS of the regression. Let's call it SSR. Tapos, dito is the residual degrees of freedom, no, which is let's call it SSE, no, kasi error din naman ang residual. Okay, so yun, you can create your ANOVA table from these values, no. So you get the same lang naman makukuha natin. We have negative 7.61, that's M1, negative 19, M2, B is negative 281, same value here. Tapos same values din yung SSR, this one, same value din for the error. Same value for degrees of freedom, and F calc as well. No? Okay, so you can make a conclusion based on this data now. gamit yung lie nest method. Okay, so ibaba ko lang to. And para lang di tayo malito, no, ibabox in ko na to. And let's call this lie nest method. To ibabox in ko din. Tawagin natin siyang move down natin. Ito, gawin natin manual method. Although again, hindi talaga siya manual. No? Kasi gumamit tayo ng Excel. Okay? And lastly, gamit naman tayo ng, let's use the data analysis tool pack. No? Okay. So if we use the data analysis tool pack, ito straightforward lang. Gawin natin is data. Tapos sa data analysis. Actually, gawin natin class, no? Label na natin ito ng price, age, tsaka area. Para pagka nag-data analysis tool pack tayo, ma-retain nyo itong mga labels na to. Okay, so let's do that. Data analysis tool pack. Let's search for your regression. Ito, this is regression. We click OK. Tapos, let's input the Y range, which is this one. And we add the labels, no? Para ma-retain siya. And the X range. The X range, again, pipiliin natin to. Okay? So, since sinelect natin yung labels, dagdag tayo ng itong labels na check mark. Tick natin yan. Itong constant is 0. Ito yung same na argument dun sa lie nest function nyo. Yung third argument kung naalala nyo. So, ang ginawa natin dun true is meaning we compute it normally, no? Dito, in this case, i-untick lang natin to si constant is 0. No? So, we are computing it again normally. We're not forcing b to be equal to 0. Okay? Then we have the confidence level. Default is 95, so that's okay. Output natin, let's just output it dito sa tabi niya. No? Output range. Then, gusto ba natin ng residual plots? Lagay tayo ng line fit plot, no? Just to look at the function. Okay? So we have nandito yung R squared value natin. R squared is 94391, same value. We also have the adjusted R squared, no? Okay? Pero right now, hindi naman natin tinitingnan muna yung adjusted R squared, no? So, again, adjusted R squared is pagka tumaas yung value ng adjusted R squared, we say na the model or the additional value fits or improves the model. Pagka hindi siya tumaas, ibig sabihin hindi siya nag-improve the model. So the way you use adjusted R squared is, may ganito tayo. So meron tayong adjusted R squared. So itong 0.88. Tapos kunwari lang magdagdag tayo ng new data dito. Let's just say, ano bang pwede idagdag natin? Area, let's say price, area. Ano magandang additional factor? Cottage, no? Holiday cottage. Temperature, sige, sabihin lang natin temperature. So, kunwari lang nakaka-affect yung temperature ng sa price. So, pwede sigurong average temperature. So, kunwari mga ganyan, no? Let's just say meron tayong kunwari ganyan yung data natin. May temperature. So, kunwari meron tayong additional data na temperature, mangyari is if you did these calculations again, you'll actually have a new adjusted R squared value. Tapos yung adjusted R squared value nun, i-compare nyo with this original adjusted R squared. So if you see that it jumps up, and I can probably show you, no? So madali lang naman. Let's do data analysis toolpack, regression. Tapos dagdag natin to. So we add a new, and let's output lang natin siya in a new, sorry. New worksheet na lang na. Okay? So if we add that, so magkakaroon tayo ng new sheet, itong sheet 2. Tapos you can see, if you look at the adjusted R squared, it's 0.89, no? So, pangit to na example kasi napaganda niya yung model, no? So let's just say, i-randomize ko lang to, no, para sure tayo na so I want to show you guys something, no? Kunwari yan. Ulitin ko lang, ha. So let's do that again. Data analysis toolpath, regression. Tapos, tama naman. Let's just say new. So, gumanda pa rin. Maganda ba nilagay kong maganda pala nilagay kong values. Sige, completely random para sure tayo na. Ulitin ko lang last. Let's do data analysis toolpath. Okay. Ayan. Okay. So, ito class, no, if you look at it, yung R squared natin ngayon is 9.94391. And when we added a new term, you'll notice na tumaas pa rin siya, no? 391 naging, or parang hindi masyado nagbago, no? Tapos may cases pa na tumataas tong R squared value. Okay? So kung titingnan lang natin yung R squared value, ito yung sinasabi ko from last meeting, no, na the R squared value actually has the tendency to overfit, no? So the more data na ilalagay mo, the more yung R squared natin seemingly increases, no? So may prone siya to overfitting. So to counteract that, that's why we use adjusted R squared. Kasi si adjusted R squared only increases when the new factor that you've added actually improves the model. So you can see na since nag-random lang ako ng data dito, so sure na dapat na hindi siya mag-improve sa model, no? So you can see na from here, 0.88 yung adjusted R squared niya. Tapos nung dinagdag natin yung random na factor na yon, parang sobrang bumaba yung value from 0.88 naging 0.77 na lang yung adjusted R square. So that's how you use adjusted R square. Pero I think sa course na to, hindi naman kami magbibigay siguro ng ganitong problem. Or at least in the past, no? In the past, we rarely, or as far as I'm aware, no, when I handle this course, wala pang problems binibigay about adjusted R square. But it's still good to know, no? Lalo na pagka when you are, for example, mayroon kayong studies, no? So kunwari sa future studies nyo, tapos gusto nyo mag-add ng factors to the model to help improve it, tapos gusto nyo malaman if it did indeed improve the model, then you can use adjusted R square. So it's still good to know these types of things, no? Okay? So delete ko lang kasi this is just random, no? So delete ko lang to. So dito sa it gives you a bunch of plots, no? So this is the age line fit plot. Ito yung plot for the age na factor. Ito yung plot for the area factor. So separate plot siya. Okay? So tapos dito you have your different, again, yung regression statistics natin. Tapos after that, you have your ANOVA table, and this ANOVA table is the same ANOVA table dun sa na-create natin, no? So we have regression, error, and total. Again, error is just residual. Tapos same SS value, same MS, and same DF. Tapos FCalc and p-value. Ito yung significance F is just a p-value, no? Then you have your tables for the coefficients, and the thing you need to look at here is ito, no? Intercept niya is negative 281.43, which is just the B. Age is the, and ito yung maganda class, no, pagka ang ginawa nyo is, kumbaga, nilabel nyo yung headers nyo or labels nyo as the name of the factors themselves. Kasi pag ginawa nyo yung data analysis toolpath method, makakarry over yung mga labels na yun. So you can notice na dito na carry over yung age, area, tapos dito rin age and area. Okay? So it's quite helpful lalo na pag ano no, you have multiple factors and parang medyo nakakalito pag ang ginamit niyo is mga coded na ano no, na factors like A, B, C, D or A1, A2, X1, X2, X3, etc. Okay? Ito, yung age natin, um the intercept for the age, this is the intercepts, no? Ito yung mga, or sorry, this is the coefficients. So ito yung beta naught, beta 1, beta 2, beta 3, etc. Or this in our case, no, it's B, M1, M2. Okay? Tapos ito yung standard errors. Yung standard errors ay dito sa Linus function, ito siya. Standard errors. Sa course na to, hindi natin ginagamit tong standard errors, no? Then you have your t-statistic. Ito, gagamitin to pagka nagko-compute tayo ng interval, no? I think the module actually has a parang a section on explaining the interval, no? So the interval is similar to yung na-discuss natin sa start ng ano natin um, ng course na to where when we talked about confidence interval, no? Trying to find where uh, at a certain level of confidence where the true mean or true variance or whatever lies, no, lies between two upper limits and lower limits. So ito siya, gagamitin nyo to solve for the lower and upper limit, and actually ito siya, no, itong lower limit and upper limit. Okay, lower 90, same lang to, upper 95, lower 95. Okay, I'll have, are they the same value? Or they're the same value, no? Kaya pala, nagtataka ako, ba't kaya naulit tong two columns na to? 3875.6, 3873, 3312, 3312. Okay, they're the same values class, no? Hindi ko lang sure kung bakit siya naka-separate pa. Baka pag nag-input ka ng ano, I believe if you input a unique na ano tawag dito, confidence interval. So kunwari naglagay ka ng 0.9%, 90%, baka ilalagay niya dito tapos i-compare niya with 95% because 95 is the default. That's just my theory, no? Kaya siya nag two columns. Okay? Tapos nandito yung p-values, and this p-values are actually important class, no, para malaman mo if parang significant ba yung factor or not. So if the p-value is the same rules apply, no? If greater than 0.05 siya, then significant siya dun um, sa linear model mo, kumbaga. So, kunwari itong coefficient na to, it's greater than 0.7, is actually very large number, no? So, posible na hindi talaga siya yung true intercept ng multiple linear regression to kasi sobrang high ng p-value. Age as well. Actually, lahat sila mataas yung value, no? So, age has a very large p-value, meaning most likely hindi siya yung true intercept or true coefficient ng x1 at ito, and same much the same way itong area din hindi din siya yung true coefficient ng x1, no? So that's how you interpret the p-value. So if there were questions like if you were to redo the experiment tapos and leave out yung mga factors that are not significant, then which factors will you leave out? Kunwari lang may mga ganong questions, no? So, pagka ganon, then you, if you do linear regression model analysis, then you look at these p-values, no? This will be a guide for you to determine kung alin sa kanila yung significant or not. Okay? Another way of interpreting it is if the p-value is greater than your alpha value, then your intercepts becomes your coefficient becomes 0, no? Parang ganun. So, para mangyayari dito is magiging y is equal to 0 times x1. So, parang mawawala tong term na to. Okay? So, ang matitira lang sa'yo is um, yung significant na factors, no? So in this particular case, parang 0 sila lahat, no? Kasi magiging parang y is equal to 0 plus 0 times x1 plus 0 times x2 siya. So parang sinasabi dito is the y has no linear relationship with any of the, or ito yung maging model, y equals 0 lang yung model because it has no significant linear relationship with the two factors. And to be fair, ano din, no, by the p-value, nakikita din natin na not significant siya. Okay? Okay, so let's do an example. Let's do another example, no? Something that has a significant value para lang mas ma-illustrate natin siya, no? So let's do itong ano, meron natang mas, well, let's try to do this one before we take a break, no? Try natin to. Let me copy. Although, sobrang daming values na. Isusulat ko lang to, no? Tapos okay. Parang tama naman. It's some sort of design to, no? I think this is a designed experiment because if you look at it, parang I don't know, may certain treatment combination siya. Pero those certain treatment combinations can be analyzed using linear regression analysis as well. No? Okay, so input lang natin to. We can start with 30, 60, 175, 15, and mukhang may pattern naman. So 15 to 8, puro 15 to. Next is 25 hanggang 16. Okay, next. Tapos 20 hanggang 22. Sorry. 20 hanggang 22. Observation number 22. Tapos 23 is 10. 30 sa 24 and yung remainder hanggang 30 is 20. Okay? Tapos ito 175 hanggang observation 4. Then 2 to 5 hanggang 8. It's another 175. Mukhang alternating nga lang ba ito? Hindi pala. Hanggang 12. And then sa 13, 2 to 5 ulit. Hanggang 16. Then we have 200. Then 20. Then sa 21, 150. Then 250. And then 200 lang. The rest of the way. Tama ba? From 23 to 30. Okay? 2 more columns. 60. Parang alternating siya, nakakaduling to. 90 and 90. Alternating siya hanggang 8. No, copy natin 2 times. 9, 10. Hanggang 16 pala. Tama ba? Tama naman class, no? 60, 60, 90, 90. Hanggang 16. Tapos 75. 55, then 45. 105, then 75 na. Hanggang dulo. Okay? Then ito, alternating 30, 40. Hanggang 16. Haba. Tingnan nyo class, no? Kung may mali sa if you spot anything wrong with what I'm typing, just let me know. Tapos 25, we have 45, and 35 hanggang dulo din. Okay. Tapos last is, ito na, 26.2, 26.3, 39.8, 39.7, 38.6, 35.5, 48.8, 37.8, 26.6, 23.4, 38.6, 52.1, 39.5, 2.3, 43, 56, 35.2, 46.9, 22.7, 58.7, 34.5, 44, 5.7, 41.8, 36.5, 37.6, 40.3, 46, 27.8, 40.3. Okay. So let's put some labels. This is force, power, temperature, and time. And yung yield natin is the strength, which is our Y value. No? Okay. Okay, so ito yung X1, X2, X3, X4, and this is our Y. Um, we can do, gusto nyo ba lahat ng methods gawin natin or shall we do the two simple methods lang? Would you like to see the manual method as well? Okay, sige. Kasi most likely, yun naman yung gagamitin nyo, no? Si Linus tsaka data analysis. Okay, so let's do Linus and data analysis. So let's, yung first is Linus. Ang gagawin natin is yung known Y. I don't believe si Linus kaya niya maglagay ng labels. No? So the Linus only can take in the X values, the exact, I don't know, yung data alone, hindi niya kaya ng label. So yung known Y, tapos ang gagawin natin is true. No? So again, first is we do not set it to b equals 0. So that's why we place true. Tapos ito for additional stats. Okay. So we have this one. So ang importante sa atin is we do the ANOVA, source, SS, DF, MS. We have regression. Tapos error. I'm sorry class. This DF is actually for ano pala no, the error and not the regression. Kasi if you notice, ito total, yung total DF natin is equal to 30 minus 1, tama? Which is 29. Regression natin is 4 because we have 4 factors. So that's why si DF is equal to 25. So correction, kasi ang sinabi ko ata dito is yung DF na to 2 is the DF of the regression, no? When in fact ito yung DF ng error. Okay? So we have the DF ng error, tapos SS natin, nakakalimutan ko to, no? SSR, SSE, okay. SSR is the left one. So ito siya. So this is one. Let's use equal sign, no? Para ano. And SSR, this is SSE. SS total natin is sum square ng Y natin. And we can double check it with using this one, no? Tapos sum of this one. And if you're wondering how I'm doing this, no? Kasi baka interested kayo malaman ko paano yung shortcut. So when you select the first one, tapos gusto nyo ma-select yung all the data up to the bottom, yung hanggang ma-reach na yung isang blank na cell, gawin nyo lang is Control, Shift, tapos down. So para ma-select nyo lahat. Okay? So sum squared divided by count. So if I select this one, tapos again, ang gagawin ko is Control Shift down. Okay? So I get 2325.26 and i-double check natin, no, if I select this 2, tingnan natin yung nasa baba. If you look at it dito sa baba, ito yung sum niya 2325.26 which is the same value. So tama yung 2 values na to. Okay? Then MS It's equal to SS over DF. Drag it down. F calc p-value conclusion. So F calc natin is we have F calc. What is F calc? MS over MSE. Okay. And then the p-value is F dist RT nito degrees of freedom 1 regression, degrees of freedom 2 is for the error. And we have an extremely small value, no? If you look at it, that's almost close to 0, no? Times 10 to the negative 6. So we have significant siya. Okay, so there is a significant linear regression between the 4 factors and your strength, no? Which is your response. Okay? So meron ba tayo na miss out? Yung model pala. So y is equal to, if we look at it, is equal to, and we start from, ito, M3 to, no? Hanggang B kasi ito eh. So let's start with the M1. So 0.21 times X1, which is force, plus 0.498 times X2, plus 0.12 sabihin natin 13 times x3 plus 0.26 times x4 plus yung minus 37.47. So again, yun yung tandaan yung last, no? Itong bilang nito is pabaliktad, no? So this is for x4, M4, M3, M2, M1, B, yung intercept. Or in terms of beta, that's beta 4, beta 3, beta 2, beta 1, beta naught. Okay? So ito yung final model natin. Now let's look at the no. So this one, sabihin natin, this is your line nest method. Now let's try data analysis toolpack naman. So we do data analysis toolpack. We select regression. Let's input the Y range. And again, dito isasali ko na yung labels, no, para ma-carry over yung labels. Then dito, let's select force to time. Ganyan. Tapos let's do labels. Constant is not equal to 0. So untick that. Confidence level, default lang tayo. And let's output it dito lang sa no? Dito sa tabi. Okay. Line flip plus. Yeah, let's do that. Tapos press OK. And you'll end up with ito, no? And let's just set ano ko lang to. ANOVA. Let's check. Same ANOVA. So if we add a conclusion here, we say significant. Tapos you look at the p-values for the no? Actually, makikita natin dito. This is intercept has a very small p-value. That's significant. Etong si force actually hindi siya significant, no? If you look at it. So pwedeng ang magiging model nyo, you can write it this way, no? Kasi if you want to include the power which is x2, pwede rin naman siyang i-include. Pero if you were asked kung meron kayong pwedeng tanggalin, then you depend on the p-value, no? So parang dito, if you look at it, 0.32 siya, force actually is not significant. No? And as well as time. Si time, hindi rin siya significant. Okay? What significance ng each factor? Yes, sa dito sa no? Si data analysis toolpack lang kasi yung merong p-value calculations. I think you can manually calculate this, no, pero it is not taught in this course, yung manual calculations ng p-value, and line nest also does not show the p-value for each of the intercepts, no. Okay? So dito dito sa data analysis toolpack siya lang yung magbibigay ng p-value which can be used to determine which of the factors has, or actually hindi talaga factors yung tinitingnan mo as significant or not, no. Tinitingnan mo is the coefficient of the factors. So parang pagka masyadong mataas, ibig sabihin yung coefficient na yun is not significant, no. So you can say na zero siya. And in essence, parang sinasabi mo na rin na hindi significant yung factor dun sa linear model. Okay? So, you can if you want just write it down this way, no? Parang include mo lang lahat tapos sabihin mo kung significant ba yung model or not, which is determined by this regression. So, parang dito we can say na significant yung regression model na to. Tapos, this individual p-values here shows you na kung alin doon sa mga coefficients na yun is individually significant, no? So dito, in this particular case, si time tsaka si force yung hindi significant yung coefficients nila, no? Okay? So, pwedeng tanggalin nyo siya if you want a more comprehensive answer. So, as to speak, no? Pwedeng tanggalin nyo siya from the model and you end up with parang 0.21 times no, sorry. Mag-start ka with these two lang. So, x3 and x2 and x3 lang yung i-retain nyo. So, pwedeng ang bagong model nyo is y is equal to 0.498 times x2 plus 0.13 times x3 minus 37.477. Okay? So, ito mga residuals lang na. Tapos, ito yung mga individual na plots nila. You can see na meron for the force, meron for the power, may for temperature, and meron for time. Okay? So that's a regression model. And my questions ba before we take a break? Okay naman, no? The lineness and yung si data analysis toolpack method is quite convenient kasi parang sobrang bilis lang ng calculations, no? As compared to yung manual method wherein magka-create pa tayo ng nitong matrices. Okay? Wala bang questions? Can I have a thumbs up kung wala tayong questions? Can we proceed to the break? Ito may question tayo from last question before we take a break. Yung linear regression po ba is same sa Poisson regression? I'm not quite familiar with Poisson regression. No? Martin, I'll get back to you. Tingnan ko. I'll try to search it. Tingnan ko kung ano ibig sabihin niya and um, check ko kung ano siya. Okay, sa RRL. Okay. I-double check ko tapos balitaan kita. Okay, sige. So, let's take a short break. Balik tayo 10 a.m. So that's mga 15-minute break, no? And once we return, we'll discuss more about we'll discuss a new topic which is yung RSM now. This is perhaps siguro yung hardest topic for triple ME14. Okay? So I'll see you at 10 a.m. And let me just resume the recording. Okay? So, balik. PowerPoint. Okay. Okay. So, medyo mahirap tong RSM class, no, kasi medyo madami yung gagawin kasi dito eh. Tapos meron mga decision points na kailangan yung i-take into account depending sa results ng actual experiment. Okay? So, kaya medyo mahirap siya kasi kumbaga to fully appreciate it, kailangan talaga may kayo yung gumawa ng experiments kumbaga. Okay? But I'll give my best I'll try my best to give you a good representation of what exactly happens when we do RSM now. Okay? So again, RSM is a optimization technique wherein ang goal natin is to find the most effective settings for each of the factors. Most of the time kasi pag when we are and for this course we'll be limiting ourselves to two factors no para mas makita natin siya. When we do optimization, usually we end up with something that looks like this no. So meron tayong if we plot the first factor in the x-axis, tapos plot natin yung second factor natin in the y-axis. So this is our x, this is our y. Tapos sa z-axis natin, doon natin ipa-plot yung response natin or the y variable. No? So these are the two dependent, itong sa x1 and x2 or our x-axis, y-axis. Tapos yung independent natin which is our response is plotted in the y-axis. And when we do that, we get what we call as a response surface. No? So ito yung response surface natin. And this response surface is actually important kasi dito natin mahanap yung maximum ng isang setting. No? So, for example, in this plot, yung maximum, if you just visually look at it, can be found at somewhere dito sa region na to. No? Tama? So, at yun yung maximum niya. So, etong RSM na to or response surface na to, pwede din siyang i-translate into a contour plot. So, contour plots could look something like this. So, meron kang, kunwari, this biologist studied the effects of stream depth, which is his x1, tapos canopy, which is x2. Tapos, if you look at it, x1, x2, this is xy, tapos ito yung contour plot niya, which is just a parang, kumbaga, pinlaten out niya lang yung z axis, no? To show you this, itong contour plot na to. Okay, so this contour plot also gives you an idea of how the response surface could look like, no? So, you could see na ito dito sa part na to, meron tayong highest na setting, tapos dito sa part na to, meron tayong lowest na setting. So, if you were an engineer na nag-experiment, for you to be able to produce this contour plot and from this contour plot, make an engineering decision na, nandito yung highest setting ko which is at 30 depth and 25 na cover, then you have to do all the experimentation needed para mabuo tong contour plot. Tama? So you can start with, kunwari, 50, tapos 10, 15, 20, 25, 30, 35, 40. So meron ka ng data dito sa 50 na depth. Tapos gagawa ka naman ng 40 depth dito. 30, 20, 10. Tapos kung gusto mo pa higher resolution, you do 45, 35, 25, 20, 15, etc. So it takes a very long amount of time para lang mabuo tong contour plots na to or yung surface plots na yan. No? And sometimes wala tayong time para mabuo yun. So we need the most efficient way para mahanap itong maximum na to. And the way we do that is through response surface methodology. So ang ginagawa ng response surface methodology, and this is just the same example, no? Itong contour plots na to translated into a surface plot. Okay? The way we do that is we start at a random na location or a known location. So kunwari, we start at a known location dito. Tapos, i-follow lang natin yung path of steepest ascent. Kasi kunwari, if I started here, tapos nag-follow ako ng isang path dito, tapos bumaba yung value ko, then hindi ko na i-follow yun. Maghahanap ako ng kumbaga ibang path. So say for example, I follow this path, bumaba yung yield ko, then therefore hindi na yung path of steepest ascent. Tama? So, pag gumanon ako, tas hindi na bumaba yung value, change ako ng direction. Let's just say na-change ako ng direction, papunta dito, tas pataas yung value ko. So, okay yun. Susundin ko siya. Tas tumaas pa ulit yung value. So, hindi ako titigil hanggat hindi bumababa yung value. Tas pag reach ko dito sa taas, definitely pag tinuloy ko pa yun, magda-drop off ako. So, dito, pag nag-drop off ako, tapos wala nang ibang path na nagbibigay sa akin ng highest na peak, then I can say na na-reach ko na yung peak ko. Parang ganun yung steepest ascent na method. So, obviously, you can see a flaw dito, no? Or sometimes it's a flaw, pero sometimes it's parang a, kumbaga, advantage din. Kasi if you look at it, hindi naman ito lahat lang ang posibleng response surface. Tama? So you can have multiple response surface. Kunwari may peaks ka dito. Tapos kunwari at depths greater than 60, somewhere outside this range, no, pwedeng may mataas pa siyang peak dito. Kunwari may mataas pang peak dyan. So ito yung sinasabi nating local maximum lang. Within the area na of study natin, meron tayong local maximum and that's what we're interested in. So posible na meron pang higher value na not in this local area, pero higher siya. Pero in that sense, parang pwede natin sabihin na hindi na yan covered sa scope ng study natin because in practice, kunwari, anything above 60 depth is parang impractical. Pwedeng ganun yung analysis nyo. So, kumbaga, hindi nyo na aaralin yun. Wala nang sense aralin siya kasi hindi naman siya practical na aralin. So, parang double-edged sword siya in a way, no, yung responsive first methodology such that you are just looking for local maximums or local minimums. So, I say local maximums and local minimums because in most although in most cases gusto natin pinakamataas na yield, no? Pero there are some cases wherein gusto natin i-minimize yung yield, yung mga lower is better na case. So for example, if you want to lower, gusto mo na lowest amount of kunwari bacteria formation, edi gusto mo for human beings gusto natin na yung i-minimize yung bacteria, tama? So hanapin natin yung instead of peaks, hanap tayo ng valleys, parang ganoon. So hanap tayo ng local minimum if we want to optimize setting. Okay, so that's how we we analyze this response surface, and that's parang visual representation kung ano yung ginagawa ng method. So yung mga steps na ituturo ko ngayon will lead you or will guide you into finding this peak or yung valley or local maximum or local minimum dito sa response surface plot without actually plotting, no? Hindi naman natin kailangan i-plot talaga siya. Okay? So, again, method of steepest ascent. Minsan, pwede ring method of steepest descent kung naghahanap tayo ng local minimum, no? So, hinahanap lang natin yung most efficient na path na pwede nating i-take para mahanap uh, yung shortest climb, kumbaga. Okay? So, if you were to do this, yung kunwari ikaw, naghahanap ka ng ito yung contour plot, no? If you want to find the maximum na pinakamabilis na way na mahanap ng maximum na to, you follow the contour plots. Tama? Kasi if this is the contour plot, ito, if you move perpendicular to the contour plot, sure ka na mahanap mo yung maximum. Kasi if you don't move perpendicular, kunwari, ito, nag-move ka, this is the contour plot, no? Tapos nag-move ka away, malamang ma-reach mo yung mga negative na values, no? Or yung mga valleys as opposed to the peaks. So pwedeng mag-move ka perpendicular tapos dito encounter a contour plot, pwedeng mag-move ka perpendicular to that one. Tapos eto contour plot, move perpendicular to that one, perpendicular hanggang ma-reach mo tong value na to. So parang ganun yung ginagawa ng yung method of steepest ascent. Hanapin natin yung um, peaks in the most efficient manner. Okay? So to do this, actually mag-ano tayo, no? Magse-set up tayo ng region for initial investigation, and this initial investigation is makes use of a 2 to the k factorial design. Tapos mag-add tayo ng several runs known as your center point runs. Okay? So, um ito mga steps na to is explained in the module, no? Pero gawin natin is let's do an example para mas makita natin siya na kung paano siya ginagawa. Okay, so let's start with ito. Let's copy this data. Okay, so meron tayong data. Tapos, you'll notice na ito yung mga 2 to the k na settings natin actually, no? If you notice, ito siya, -1, -1. This is actually yung treatment combination na 1. This is treatment combination A. This is B and this is AB. Tama? So, for this course, ang gagawin lang actually natin na mga hanggang 2 settings lang tayo, no? Anything more than 2 settings, medyo mahirap na siyang gawin kasi, no? Or kumbaga mag-iiba na kasi yung mga formula. Unless of course, meron ba tayong examples of more than 2 settings? As far as I know, 2 settings lang yung ginagawa usually. No? Okay. Mukhang wala naman. Hindi pala ako nag-transition. Excel. Okay. So, nakikita naman to, no? So, again, itong first, itong coded settings na to. So, later I'll show you what coded settings and natural, although I've explained this in the previous na mga lessons, no? Coded versus your natural settings. Pero later, it will make more sense, no? Mas ma-appreciate natin yung kung bakit kailangan natin ma-translate from coded to natural. Okay? So we have coded settings, tapos suppose na ano no, ang region of investigation natin, this is the first initial to. Ito yung initial na region na investigate natin. We investigated at 30 to 40. Or sige, balik tayo dun sa ano no, PowerPoint. Okay? So nag-start off tayo with interested tayo na mag-maximize ng yield ng isang particular process, no? Tapos he is currently operating the process with a time of 35 minutes and temperature of 155 degrees Fahrenheit, which results in a yield of around 40%. No? So ito yung ano niya, initial region of investigation. So, good starting point yung class, no? Kung saan kayo, kung ano yung current na, kunwari, you are improving a process, kung ano yung current na settings ng process nyo, yun yung initial na gawin yung initial area of investigation. Okay? So, from 35 minutes, pwede ka na mag-set up ng region of investigation, 35 minutes and 155 degrees Fahrenheit. So, obviously, for this case, ang settings niya is time and temperature, no? Okay, so your two controllable factors are time and temperature. That is the independent variables. Tapos yung hinahanap mo na response is your yield. Okay? So, doon sa 35, you can set up kung ano yung gusto mong parang ano no, range sa low and high settings. Basta it is within that range. Dito ang ginawa niya is yung ginawa niyang region of exploration is plus minus 5 of 35. So that's 30 to 40 minutes. Tapos yung reaction time niya is plus minus 5 din ng degrees Fahrenheit. So obviously this comes to experience na no kung ano yung isa-setup nyo na region of exploration. So dito ginawa niya plus minus 5 lang din. So that's 150 plus minus 5. 155 plus minus 5 is 150 to 160 degrees. Okay? So, nung ginawa niya yung experiment, yung nakuha niyang values is ito. Okay? So, ito yung nakuha niyang values. So, ito yung sa mga, this is the 2 to the K na experiment na ginawa niya. So, ito 2 to the K design to. So, you'll notice meron siyang ito yung mga treatment combination niya, no? So, yung low-low, tapos ito yung high-low, which is the A. Ito yung low-high, which is B. And ito yung last is the high-high, which is AB. Okay? Tapos, bukod doon, nagdagdag siya ng tinatawag nating center point runs. Okay? So, may recommended number of center point runs. I'll have to double check no kung may standard number ba exactly, pero I think parang ano to you can have more than 5 runs. Pero hindi yata pwede less than 5 runs, parang ganun. For this particular case. Ang ginawa niya dito is 5 runs yung ginawa niya no na center point runs. So the center point runs are important because ito yung gagamitin para estimate yung experimental design, yung error ng experimental design. No? Okay? More on that later. No? Pero essentially, yung si center point runs is just the coded settings where or is just the settings na at the midpoint of your highs and lows. Okay? So siya yung parang initial settings no. So 35. So that's 35. Tapos minus 5 is the low setting, plus 5 is the high setting. Tapos 155 yung sa temperature naman, minus 5 is the low, plus 5 is the high setting. Okay? Tapos ang magiging coded setting niya for the center point runs is 0, no? So later magkakaroon kasi tayo ng mga star point settings no where we have coded settings of let's say 1.414 parang ganyan. So kung 1.414, we need a way to convert kasi we need to do this experimentally no ito mga yung mga setting na to. So we need a way to translate this into a natural setting which is a temperature settings kasi yun yung isa-set nyo when you do the actual experiment no. More on that later no. Pero focus muna tayo dito. Itong 2 to the K, so this is the 2 to the K part and this is the center point runs. Okay? So, let's start no. So, first ang gagawin natin is let's compute for the contrast muna. So, we can do contrast no. Tama? And para mas you can do this in two ways no. Pwedeng Yates technique, pwede ring table of signs. I usually like to do table of signs, no? And gawin ko lang A and B to class, no? Kasi mas familiar tayo sa A and B. And let's add another table for AB. So AB, yan. You can do Yates technique, pero oftentimes I find table of signs easier to use, no, than your Yates technique. So ito na lang table of signs yung gagamitin ko. So again, analyze muna tayo 2 to the K muna. So ignore lang muna natin to. And para lang ma-ignore natin to, I'll just hide this, no? No need to hide it actually sa pag kayo na gumawa. Pero ako, para lang for illustration purposes, hide lang natin para mas maano natin, no? Makita natin siya. So, let's do, unang kinocompute is contrast muna, no? Tama? Contrast. Contrast is equal to some product. I hope you still remember, no? Some product nito, tsaka some product nito. Tama? Kasi ang ginagawa natin is we add pagka naka high setting yung isang factor tapos i-deduct natin pagka naka low setting yung isang factor. Okay, so some product and we can drag it. Meron tayong, oops, mali kasi gusto nating F4 dapat tong si yield, no, kasi ayaw natin mag-move siya. Okay, so we can move it to the right. Ito na yung contrast natin. Okay? So from the contrast, pwede tayo mag-compute ng SS, pero we can also compute effects, no? So we've discussed this effects earlier, and actually for this, for RSM, importante to sa effects, no? Because we will use this to create our model. So i-compute na rin natin si effect. So effect is equal to this one times 2, tama? 2 times the effect, 2 times the contrast divided by the total number of observations, which is this count right here. Okay. So, 4. Okay, so yun yung effect natin. Later, gagamitin natin yan. Then we have your SS. Ito, SS is just contrast squared divided by total observations. Okay. So we start off with 2 to the K, as in 2 to the K analysis lang talaga to class, no? So ito siya. Meron na tayong contrast and itong SS and effect. So let's form our ANOVA table, no? So let's just write it here, ANOVA table. We have source, we have A, B, AB, error, and total. Okay. Tapos we have SS, DF, MS, SS, DF, MS, FCalc, and p-value. Then conclusion. Okay. So ito muna. Now, ang difference dito with your ano, no, mali pala ginawa ko. I-unhide ko na to. Unhide para task ko to. So ang difference ng ANOVA table na to with the 2 to the K design is that we don't just compute for the total tapos minus natin yung error para makuha yung error, no. We'll actually use the center point runs para makompute tong error. Okay? There are multiple ways to do this, no. And you can do both ways, no, para ma double check nyo kung tama yung answer nyo. So one way is to compute for the variance of the center point runs, because if you do variance of the center point runs, this actually is the MS for the error. Okay, so if I do variance ng center point runs, so that's var.s, no, kasi this is a sample data. So var.s, I get 0.043. Then if let's just compute for the total degrees of freedom, which is i-include na natin yung center point runs, no? So this becomes equals count this one minus 1. Tapos degrees of freedom nito is 2 levels, so that's 1, 1, magiging 1 nito. So error is just sum, sorry, equals 8 minus itong sum na to. Gives us 5. Tama ba? Wait lang class 5 plus 4 kasi. Let me first double check class now. Mali nga lang yung ano ata. We have 4 tapos 5. Double check ko lang class na. Doon sa ano kasi natin, we have 7 degrees of freedom. Okay. So 7 siya because sorry class. So ito, ganito pala natin siya i-compute to. Yung error kasi is kinukuha natin siya from the center point runs. So ang error natin is just actually ito, number of center point runs minus 1. So that's 5 minus 1. Okay? So parang count nitong center point runs minus 1. Tapos yung total natin is equal to yung sum lang nitong dalawa, no? Ay, nitong total. So that's why it's 7. Okay. Kaya nalilito ako kasi dun sa modules natin, it's 7. No? Okay. So 7, we have 4. So if we were to compute for SS, then this is just ito times DF, no? 0.172. Okay. So that's one way to compute it. Then actually, hindi nyo na kailangan i-compute si SS, no? Kasi once you have your MS, kasi MS lang naman importante to compute for FCalc, tama? Hindi mo naman kailangan yung SS. Okay? But another way to compute it is, and this is one way to double check, and I lagay ko lang dito, no? Error, let's just say alternative method. So another way to compute for the error is just to take the SS of the center point trans. So if we want to get this SS of the center point trans, ang gagawin natin is sum square nito minus sum nito squared over count nito. Okay? So para siyang yung SS total na calculations, no? But instead of taking the entire data, ang ginagawa natin is kinukuha lang natin yung center point trans lang. Okay? So notice na same formula siya sa yung ginamit natin na SS total, no? Which is sum square ng individual data minus yung correction factor. Tama? And this correction factor is taken from center point trans lang. Okay? If you do that, you'll actually get the same value, no? And ito, this is still the same, no? Magiging count, yan, as 1. So 4. So equals this 1 over 4 gives you MS. So you can do either, no? So pwedeng compute nyo lang yung SS nito divided by total degrees of freedom gives you MS. Or kung gusto nyo mas mabilis, variance lang diretso ng center point trans. So you can do var.s ng center point trans gives you MS. Okay? So now that you have your error and meron tayong SS dito, di ba? This is your SS. Na-compute na natin to. Say SSAB. Yan. Pwede nyo na ma-compute yung total nyo. So the total actually, although hindi naman ito na ginagamit to, pero yung total nito, hindi natin gagamitin yung parang sum of squares ng entire na yung data set. Ang gagawin dito is, since we already have A, B, and error, i-add lang natin actually to. So yan yung total. 2.995. Although hindi na masyado nagmamatter to, no? Kasi wala namang part dito na gumagamit ng SS total. Dati lang kasi kaya natin kinocompute yung SS total para makuha yung SS error. Pero this time, since meron tayong center point runs which estimates the experimental error, yun yung ginamit natin para makuha yung error as opposed to just getting the sum then deducting it from the SS of the sources. No? Okay. So, let's compute ito divided by this one. Drag it down. Meron tayong MS. Tapos from there, pwede tayo mag-compute ng FCalc. And we press F4 para ma-fix siya. Oh, sorry. Fix natin to. Then we get the p-value, which is f.test.rt. Ito, degrees of freedom 1 is source. Degrees of freedom 2 is the error. F4. Then drag it down. Then we can have our conclusion. So we can say na this is significant. Yung factor A, significant in factor B. Not significant yung interaction ni factor A and factor B. Okay? So that's the first step. So knowing which factors are significant in the first place, because kaya siya ginagawa because once na kailangan muna natin i-determine kung alin yung significant, because once a factor is significant, tsaka lang natin siya isasali doon sa model na gagamitin natin to find the steepest ascent. Okay? So dito in this case both factors are significant, so sinasama natin siya. Pagka yung factor, kunwari lang ang nangyari class is not significant to, no? Not significant si B pero significant si AB. As long as a factor's interactions appear significant, isasama mo pa rin yung main factor doon sa model natin. Regardless kung or kahit hindi siya significant no in itself. As long as lumabas siya as a significant interaction, magiging masasama pa rin siya sa model, kumbaga. Okay? So in this case, kahit ganito yung lumabas, si A and B isasama pa rin natin because significant si AB. So kahit ang lumabas actually is ganito, no? Mare, not significant si A, not significant si B, pero ang interaction AB is significant. Therefore, si main factor A and main factor B isasama pa rin sa model. Okay? So tandaan nyo yun, class, no? That's how we determine if isasama natin sa model or not. Okay? Now that we have this, kailangan na natin ma-generate yung model, no? And to generate the model, we use this calculation, no? Okay. Ito yung gagamitin natin na calculation. Okay? So y is equal to b naught. B naught here is just the b plus b1 or parang m1 to, no? So we can say na slope 1, x1 plus slope 2, x2. Now, B naught is yung intercept. So this is just the average of the factorial and center point responses. So i-average lang natin siya. Tapos si B1 natin or M1 is the effect of the factor A over 2. So di-divide natin siya by 2. Kaya importante na kinompute natin yung effects. Tapos yung B2 natin or si M2 is just effect of factor B divided by 2. Okay, tapos N will be now our number of factorial runs, no? Okay? So ito yung calculation. So ito na-compute na kasi natin, so hindi na importante. And we end up with this one. And let's compute na kung same tayo na nakuha dito. So if we go back to our Excel file. So let's compute our effects. If we take our model, saan natin ilagay? Dito na natin ilagay, no? So B naught, let's do equals average nito. We get 40.4 M1 and or sige kung gusto natin B1 yung gamitin. Ano bang ginamit sa module? Let's see. Sa module ang gamit niya na term is wala namang sinabi ata. Hindi ko mahanap class, no? So mukhang hindi naman siya particular, no? So kayo kung ano yung mas preferred nyo. For the sake of ano lang na consistency, gawin na nating B to. Sorry, B tapos M1, no? Tapos M2. Parang ganyan. So M1 natin is equal to fx over 2. Tapos M2 is effect ng B over 2. Okay? So ito yung 2 B1 po yung ginagamit. Sige, para hindi kayo malito na baka malito kasi kayo. So let's do B naught, B1, and B2. Okay? So we have these factors. So 1.55, no, sorry. So magiging ano natin, we call this as y hat, no? Y hat, this is the predicted y, parang ito yung sinasabi niya. From the model, this is the model kasi. Y hat is equal to, yung symbol ng y hat is yung y na may, I can probably draw it, no? Yung y na may parang ganyan. Sorry. Yung ganyan. That is your y hat, no? Okay. So y hat is equal to, wait lang, kasi ano ba yung feel ko mali yung spelling ko. Sorry. Y, ganyan pala yung spelling. Y hat. So y hat, tapos equal siya sa, ano ba to? This is 40.44 plus 0.775 x1 plus 0.325 x2. Ito yung model na gagamitin natin. Okay? Now, we need to check kung merong, delete ko na to, no? We need to check kung merong lack of fit dito sa model na to. Because if there is a lack of fit, kailangan natin, ibig sabihin nun, parang na, kumbaga hindi na linear, hindi actually linear yung relationship niya. Parang ang sinasabi niya is, doon sa ano natin, sa, if you go back to the ano, no, parang either na-reach nyo na yung maximum or na-reach nyo yung minimum. Parang ganun kasi yung ibig sabihin nun. Kasi kung hindi na siya linear, posible kasi na parang curved na yung surface mo. So kung curved na yung surface, it indicates na parang may peak ka na. Okay? So kailangan mo kailangan natin i-convert yung model natin from a first order model into a second order model. Okay? So right now, yun yung first step, no. I-check muna natin kung naka first order model pa ba tayo, kung linear model pa ba. And the way we do that is through checking for lack of fit. So or sometimes we just abbreviate it as LOF, no. So i-check natin yung LOF. So the way we do that is create tayo ng additional columns dito. So create tayo ng additional columns. So if this is our Y, yung Y predicted natin o Y hat, tapos yung sa Y hat, create din tayo ng, and kaya ko ba maglagay ng Y hat symbol? Double check. Baka merong pwede copy paste ko na lang. Ito. Okay, meron ako na hanap. Y hat. Tapos, maglalagay kasi tayo ng extra columns, no? We call these columns as your parang yung residual na columns, no? So we need this for us to be able to compute for the SS ng model natin, pati SS ng residuals natin. Okay? Tsaka from there, makakompute din tayo ng SS ng lack of fit. Okay? So, dito, this is Y hat. Yung Y hat natin is equal to, that is 40.44 plus 0.775, and I'll just plus F4, no, para ano siya. para ma-fix siya, multiplied by x1, which is, ang x1 natin is this one, coded settings. Ito, x1. Tapos, minus 0.325 multiplied by x2. Okay? So, yun yung predicted natin na y, no? And we can drag this down. And tama ba? Let's drag this down. Plus. Sorry. Thank you for the correction. This plus. So, ito yung magiging parang predicted values natin, no? Okay? So, that's our predicted values. Tapos, ang gagawin natin is, compute natin yung SS ng model natin tsaka SS ng total using this predicted values, no? Okay? So, we'll set up two more columns, yung Y bar tsaka ang B naught. Hindi na F4 ang B naught. Yes, that's correct, no? Thank you for the correction. Ayan, yan. Mas nagme-make sense na yung values natin. Okay? Ito yung predicted natin. Ito yung, this is the predicted value. This is the actual value from the experiment. Okay? So from here, create tayo ng two more columns, no? We'll have the y minus y bar, y minus, y minus y minus y hat, which is actually, this will give us the SS model, no? Ito yung mga, dito magagaling yung SS model. Sorry. Dito magagaling yung SS error. Tapos yung y hat minus y bar, dun manggagaling yung SS model, no? Okay. So, create tayo ng two more columns. So, ito y minus y, y minus y hat. Then we have your y minus y hat minus y bar. And I can probably get the y bar symbol na para mas malinis. Ito, may hinahanap ako. So y minus y bar is just actually hindi ko kailangan gawin ito, no? Let's do this. So magiging y minus y bar average lang ng y bar, no? Let's do F4. F4. Okay. And if we take the sum of squares nito, ng y minus y bar, that should give us the SS of the model, no? Okay, so this is actually SS of the model. Okay, pero I think we can also do sum square. Let me just do this class now. This should give us the same value if I do sum square divided by same lang. So anytime kasi anytime you use y minus yung mga ganitong form, y hat minus y bar na form, it's just the same as pag gumamit kayo ng ganitong form, no? Okay? So pwedeng you can solve it either way, no? You can make an additional column for y hat minus y bar. That is SS model. Or pwede ring i-diretso na ito. You just parang yung same na formula na ginagamit natin parati sa SS total. Yung sum square minus yung parang correction factor, quote unquote. So, pwedeng ganun, no? You can do either way. Okay? Ito, if I do some, definitely ito, kailangan mo ng additional column, no? Kasi, iba siya eh. So, actually, hindi ko na kailangan yung y minus y bar, no? Pero, if you want, pwede rin naman, pag kinumpute mo y minus y bar, this is just y minus yung average. And we press F4. Tapos, if we do some square nito, this is just also equal to ito. Equal lang to pag ang ginawa natin is sum square nito minus yung correction factor na type of equation square divided by count to. So you can solve it either way. No? If you look at it, same lang yung nakukuha. So this is actually SS total. And this is SS total as well. So, kayo bahala class no kung ano yung mas preferred nyo na method. And para lang mas i-drag ko na lang dito sila lahat kasi para nasa SS sila na column, no? Para mas malinis lang tingnan. Okay? So this is model. No, sorry. Nag-iba na ba? Bakit nag-iba? Siya nag-iba. Huh? Minus average. May ginawa ba ako mali? G3 minus average. Ba't yung sinama? Okay. Kasi hindi na F4 yung kabilang side. Okay. Same na? I think same na. Okay? So you can compute it either way, no? Yung SS model. Now, ang kulang na lang natin is yung SS pure, no? Which is, na-compute na ba natin yun? Yung total error was already computed. Yung siya yung nandito. Ito from the 1722. Oh. So, sige, buuin lang natin yung ANOVA muna no, para mas malinaw. ANOVA source. Tapos, we have SS, DF, MS. Tapos, FCALC, p-value, conclusion. As these are sources, we have model. Tapos, we have your error, which is actually made out of 2, no? Itong error na to, and itatab ko siya para mas malinaw. We have your lack of fit, tapos meron tayong yung pure. Okay? Tapos, yung last natin is the total. So, the total, this is the total error. Model is this one. Total error is the total minus the model. So, 17722. Tapos, i-compute natin yung pure, which is, I believe, this is the pure, no? Ito. That's your pure error. Okay? Ano? Hindi. Iba yung pure error. 1732 kasi from the slides, it's 1732. Of the center point runs. Okay. So, kailangan natin siyang pero ito yun eh. Sum square nitong value. Wait lang class ah. I'm trying to minus predicted. So, kailangan natin yung let me double check class ah. Yung pure kasi natin, we need to find the pure error. Which is, let's review the slides now. Is the sum of the ano. Tama nga, 172. Bakit magkaiba? 173. Baka nag-round off lang somewhere. Okay? Give me 1 minute class. No? I-ano ko lang. Investigate ko lang kung bakit. Doon sa modules kasi natin, it's different from the, from the PowerPoint. Kasi it should give you the same. Kasi nag-y minus y hat siya, no? Sige, let's try to do that. Nag-y minus y hat kasi sila. And ang ginawa niya is y minus y hat. Tapos if you get the sum of squares ng total, gives you the total na sum of squares. So if I do, kunwari, sum square nitong lahat, this gives me the total, which is itong 1772. But if I take the sum of squares lang ng center point runs, which is this one, this gives me 17321. But it should also be the same as this one. Pero apparently it's not the same, no? And nag-round off lang ba to? And even if I extend this, hindi siya nag-round off. I'll double check this, no? Kasi this is what I remember. Pero I could be wrong. And even sa slides, ito yung pinapakita, no? Itong 172. Okay. Anyway, sige. Ito, sorry, ibalik ko sa screen, no? So if we try to construct class, no, construct tayo ng y minus an additional column, which is the y minus y hat column. So i-minus lang natin yung actual yield minus the predicted yield. We should get something like this. Tapos if we take the sum of square ng if we take the sum of squares of all the y minus y hats, we should get the SS error total, yung SS total error, which is already computed dito kasi ang ginawa lang naman natin is total minus model. No? It should give us the same value. So you can notice na ito, this is the same value as this one. Pero if you get the sum of squares of the center point runs lang, so if you take the center point runs, which is ito, sum of squares of these 5 values alone, yung y ng center point run minus the predicted y, you should get the sum of squares of the pure. No? So this is pure, this is total. Okay? So the pure should be equal to this one. So if I get the lack of fit na error, so take note again, yung total error is comprises of the lack of fit pati yung pure error. So if you want to get the lack of fit, we just take error minus total error, that I should say, the SS of the total error minus the SS of the pure error, which gives me 0.00401. Okay? And again, kaya ako medyo nalilito class no because if you look at the slides, and I'll double check this para sure tayo, no? If I look at the slides, ito, 0.005 yung ginamit niya. Kasi yung ginamit niyang pure error is the same pure error as the ANOVA 1, no? So I'll double check this. Tapos sabihan ko kayo kung ano yung exact na value, no? Pero in any case, let's just assume na ito muna, no? Yung ginamit natin. LOF. So if we do this calculation, so 0.004, we need the degrees of freedom, no? So the degrees of freedom for the sorry, hindi pa tayo ng screen. Degrees of freedom for the regression model is 2 because we have two variables. Yung degrees of freedom ng error natin is equal to n minus k. Yun yung degrees of freedom ng pure error, I should say. So that's the um, total number of runs minus the distinct na x variables. Tama ba? Sorry. Of observations. Let me do that again, no? The total degrees of freedom ng model, again, nasulat ko na ba? We have 2. Yung total natin is equal to total number of runs, which is this one. Minus 1. That gives us 8. Dito na tayo sa error, no? So error is equal to definitely ito minus dito, no? So that gives us 6. Tapos ang kailangan lang natin is i-break down tong 6 into the LOF na error tsaka yung pure na error, no? So the pure error is equal to total number of observations minus the number of levels of the independent variables. So we have capital N minus N. So we have total number of observations is 9 minus each level is 4. Hindi, parang mali. 2, 4. Excuse me, 5. May mali sa calculation na to. Okay. It's center points minus k plus 1, which is yung k natin is the number of factors, no? That is the lack of fit na error. So we have 5 center point runs. That's 5 minus we have 2 factors per we have 2 factors in this experiment, no? That's x1 and x2 plus 1. So that gives us 2. So if we compute for the lack of the pure error, that gives us itong 4, no? Okay? So we can now compute for the the lack of fit. So actually hindi natin kailangan i-compute tong itong si model. Ang kailangan lang natin is itong si lack of fit, no? So we take the lack of fit na MS, and we also take the pure na MS, which gives us this one. Okay? So once we have that, compute natin yung F-calc nila. So again, ang purpose lang ng ANOVA na to is to check if meron bang lack of fit sa data natin. So we do MS divided by the pure error. So it gives us 0.0463. And if we do F this RT nito, degrees of freedom nito is 2, degrees of freedom nito is 4, gives us a p-value of 955. Therefore, not significant siya. And since not significant ang lack of it, therefore we can say na kumbaga, there is not enough evidence to show na may lack of fit yung data. So meaning, the data does fit the model. So kung whatever data na nakita natin dito fits the model, which is this model right here. Okay? So we can now say na since nagfi-fit yung model, pwede na natin ito na yung kumbaga ang steepest ascent run, steepest ascent run na gagawin natin. Okay? So now that we have the model and we've proven the model adequately fits the data, we can now perform the method of steepest ascent. So, okay, so to perform method of steepest ascent, kailangan natin mag-move away from the design center, no? Which was, in this case, yung x1 was equal to 0 and x2 is equal to 0. And again, this is coded settings, no? Ito yung mga coded settings natin. So, ang gagawin natin is mag-move tayo in increments following this formula, no? So, that is yung change in x1 over b1 should be equal to change in x2 over b2, where b1 and b2 are the coefficients in the model. So, okay? So, for example, dito, kunwari lang ang based on the experience of the chemical engineer, sabi niya na mas okay mag-move tayo ng increments in terms of 5 minutes. Okay? So, pwede din naman na mag-move ka in increments of kunwari instead of si time yung minumove natin, pwede naman ang i-move natin is yung temperature. Okay? So, dito lang, based on his experience, he chose to move it in terms of time muna. Tapos, kumbaga, magpa-follow na lang si temperature based on the increments of the time. Okay? So, if the time is 35 minutes, that is your zero starting point, no? Tapos, you move in increments of 5 minutes, and then therefore yung each increment mo each increment will be equal to 1. Okay, to solve for the coded temperature increments, gagamitin natin tong formula na itong ratio na to. Delta x1 is over b1 is equal to delta x2 over b2. Okay, so delta x1 is equal to 1, tapos si delta x1 is equal to 1, so that's 1 over 0.775. If you multiply that by B2, this should give you X2 is equal to 0.4194. And again, itong increment na to is coded settings pa lang, class, no? So, again, ang difference ng coded settings and natural settings is that si natural settings, sila yung actual na settings na sineset natin dun sa parameters ng natin ng operation. Okay, so kunwari yung 35 minutes, 155 degrees Fahrenheit, those are natural settings. Si coded settings is strictly exist for the statistical analysis. Okay? So, ang pinili niya kasi is delta x1 of 1 unit, which is translated as 5 minutes, no? Na 5-minute increment based on yung formula na to. Meron kasi tayong formula for for the coded na for converting a coded factor into a natural factor, no? So if ito siya, para sinasabi lang nito is the coded factor is equal to just the x prime, the natural factor, minus the center point divided by the high setting minus the center point. So doon sa example kanina wherein nag-move siya from 30, kunwari nag-move siya from 35, sige, papakita ko to, no? Wait lang, class. Let me get my tablet. Para mas ma-imagine nyo. Okay. Sige lang class, nag-open lang yung ano ko, whiteboard. Okay. So, okay. Ano yun? Yung formula kasi is the coded settings. We have coded settings is equal to yung natural settings natin. Ulit yun. Natural settings minus the center point setting over the center point. Over the high setting minus the center point. Okay? So let's take the temperature example, no? So sabi doon, we move from 30, which is yung center point setting natin is 30. No, sorry. Balikan natin, no? Ang center point natin is 35. Tama? So let me show you, no? Sabi dito, ito class. So ang center point setting niya is 35 and 155 respectively, no? So gusto niya na mag-move out from this center point settings using the model with increments sa time in increments of 5 minutes. Gusto niya tig 5 minutes nag-i-increase siya. Okay? So if you do that, so parang ang ginawa niya is ganito, no? So that's saying na you have from 35 mag-move ka plus 5 to 40. So parang ganyan. So that's 40 minus yung center point mo is 35 divided by yung high setting mo for this case is actually 40, no? Minus 35. So this is moving will actually give you x is equal to 1, no? Kasi parang kumbaga nasa high point setting ka. So you are moving from x equals 0 to x equals 1. Tama? So kaya ang delta x mo is in increments of 1. So kung magmo-move ka from kunwari uh, you're moving from 1, you are moving in increments of 1, no? So magiging ang setting mo is from 0, 1 kung coded to, no? This is coded x1 coded. Let's just say x1 coded. Ang mangyayari dyan is you'll move from 0, 1, 2, 3, 4, 5, 6. And you'll find out na yung mga coded settings na to translates to yung 35. This is 35. This is 40. This is actually 45. And you can compute it now. So let's try 45. So if you do 45, 45 minus 35 is equal to 10. Tama? 10 over 5. So 10 over 5 is equal to 2. Tama? So that's 45. Tapos ito, this is actually 50. So you can also do that, no? Kunwari 50. So 50 minus 35 is 15. Over 5 is equal to 3. Okay? So kaya ganyan siya. So every one increment of the coded setting is actually 5 minutes in the natural settings. Parang yan yung sinasabi sa relationship na to. Okay? So, kung mag-move ka 35, 40, 45, 50, and this is 55, etc. dot, dot, dot. So, mag-move ka downwards. You increase the increments of the of your first setting of your first factor, then you also increase the setting of your second factor. Pero yung increments nito should follow the ratio delta x1 over b1 should equal to delta x2 delta x2 over b2. Okay? So, kung yung factor mo yung first factor mo magmo-move siya in increments of 5 minutes, ano yung increment movement dapat ni degrees Fahrenheit para masundan mo yung model? Yun yung parang sinasabi dito. Okay? So, if you use 1 over 0.755 ata yun eh. Ito. Like just, ano no. If you use 0.775 is equal to delta x2 over 0.325. This gives me, pagka sinolve ko to, this gives me delta x 2 is equal to 0.4194. 4194. So ngayon, if I want to do the incremental movement of my x2, I'll move from 0.4194. Tapos from 4194, you'll move from, hindi nag-work yung out ko. So you start with 0, no? Siyempre, center point tayo mag-start parati. So that's 155. Then you move in increments of 0.4194. Tama? So yung next is 0.82. I-multiply mo to by 2. So 4194 divided by 2 times 2. 0.4194 times 2 gives me, 0.4194 times 2 gives me 0.8388. This is 0.8388. Okay, so that's 0.8388. Tapos, etc. etc. So, i-move mo to in increments of 0.4194. And this will give you may equivalent to na natural settings kasi again hindi mo naman pwedeng i-input to as a parameter doon sa actual experiment mo. Kailangan mo i-input to as a parameter setting doon sa temperature. So for you to be able to convert this, gagamitin mo yung formula ulit na to. Okay? So for your X2 setting, you have 0.41, ito yung coded setting mo, no? 0.4194. Tapos, hahanapin mo yung, kumbaga, natural setting that corresponds to this 0.4194. So, we just multiply this by the high setting, which is, in that case, was 160 yung high setting, no? Minus 155 is equal to x prime, which ito yung hinahanap natin, minus the center point setting, which is 155. So, if you do that, magiging, ano siya? Magiging, let's do calculator. 0.4194 times 0.1494 times 5 plus 155. So 157.097. So I'll just say 157. Send natin. Up. 157.1. Sabihin na lang natin 157.1. Okay? So ito yung natin. Magiging incremental na movement of the natural settings. 157.1. Tapos gagawin nyo yan every treatment combination hanggang dumating kayo sa point na hindi na tumataas yung yield. So later I'll show you what this means, no. But there's one question here. Constant po ba yung highest setting na ginagamit for each runs? Uh, Hindi ko masyadong gets yung tanong. Do you mean for each experiment? Ang highest setting na sinasabi dito is for the for the initial 2 to the K setting na ginawa natin. So, di ba may ginawa tayong 2 to the K setting na wherein, kunwari sa time, ginawa natin is 35 plus minus 5 siya. So, 35 plus 5 was 40 yung high setting natin. Tapos, doon sa temperature, it was 1555 plus minus 5. So, yung high setting natin for temperature was 160. So, when we want to convert for the incremental runs na ngayon, based on, kasi again, ito naman na-produce natin yung model from the experimental design of the 2 to the K with the center point runs. So kaya yun yung gagamitin natin basis to compute for the natural settings. Okay? Pero definitely kunwari nag-ano na tayo, no? Nag-shift na tayo, kunwari nakahanap na tayo ng new area or new region for investigation, magse-set na tayo ng sarili nating bagong new high point and new low point. Okay? And actually, kumbaga hindi naman to nagmamatter na, hindi naman HS minus CP all the time, no? Pwede naman, if you want, you can also use CP minus LS, yung low setting. Kasi these are equivalent, no? Same lang sila. Kumbaga, ano yung plus minus na ginamit nyo. This is actually just the plus minus na doon sa ano natin, no? nung sinet up natin yung 2 to the K. Okay? So ang ginawa natin is we set up the high points, the high point and low point settings. So meron tayong increments na ginawa. So when we want to perform the experiment, we do the actual experiment, no? Kunwari, let's just say na ginawa natin yung actual experiment. You started with a center point run. We have 35 plus 155 yung isa-set up mo na parameters sa natural setting. So ito yung kumbaga yung ini-input mo mismo doon sa actual experiment mo. So if this is I'm assuming parang ano to, no? Parang reactor. So mayroon kang reactor, tapos yung reactor kaya mong i-set yung temperature, saka kaya mong i-set yung how much time before you stop the process, no? Or before you record whatever yield you are looking at. So meron kang reactor, sinet niya 35 minutes, magra-run yung reactor at 155 degrees Fahrenheit. Tapos yung nakuha niyang response is percent yield is 40.44. Okay? So let's just say yun yung nakuha niya. Tapos next, magsi-steepest ascent runs tayo using the increments na ginamit natin. So again, ito na yung part na, itong pag-setup na to, ito na yung part na kumbaga sinusunod na natin yung etong curve na to. Sinusunod na natin yung path na to. Na-set up na natin yung model. Etong line na to is actually the model that we've set up. And when we are moving, when we are doing the increments, we are actually moving within this model. Okay? So nagmo-move tayo along this path. Okay? So this is just an example, no, class. Dito, kunwari lang nag-steepest ascent runs kayo, tapos ang ginawa is, natural setting is 40 time 157 degrees Fahrenheit, tapos ito yung nakuhang yield. So tumaas ang value, meaning pwede pa tayong valid pa yung model, kumbaga nagmo-move up pa tayo. So we do the experiment again this time. Ang ginamit naman natin is plus 5 tayo sa time, tapos plus a certain value tayo doon sa temperature, which is in terms of increments, it's 0.4194, no? So plus 4194 tayo doon sa incremental increase, which translates to a temperature of 159. So kunwari ganyan. So nag-move up tayo, 41.9. So nag-increase pa. So okay pa ang model, hindi pa siya nagbe-breakdown. This still works. So we do again the experiment. This time higher naman. Increment of delta x1 is 3 na ngayon. So 3 na yung increment niya. Tapos si x2 is 1.25 na, which is just 3 times itong 0.4194. Okay, so you input the natural setting, which is 50 and 161 respectively. You get a response value of 43.1. So again, it's still increasing. So you do this all over and over again. Kasi you are still, ano no, and take note that this particular case is a, ano to no, a case wherein higher is better, parang gano'n no, na you want to increase yield. Obviously, if it's a lower is better situation na pag optimization, then obviously hanapin mo yung path of steepest descent naman yung hanapin mo. Pero in this particular case, steepest ascent tayo. So you do it over and over again, incrementing the time positively and incrementing the temperature positively din. So mag-increase ka ng time, mag-increase ka ng temperature based on the ratio na sinelect na or na compute natin kanina. So kunwari lang umabot ka sa 10th increment ng time, which now translates to 85 minutes. Tapos and sa temperature, it translates to 175 degrees Fahrenheit. Tapos umabot ka ng 80.3. So, syempre at this point sobrang taas ng ano no, ng yield mo na, pero hindi pa rin nagbe-breakdown yung model no, mataas pa rin naman siya. So, you do it again. And now on the 11th na ano increment for time, you notice na itong 11th increment translates to 90 minutes and 178.067 na degrees. 178 degrees Fahrenheit. So once you do this, you notice na nag-drop yung yield. Okay? So what does this mean? Pag nag-drop yung yield, ibig sabihin hindi na siya yung kumbaga na-reach nyo na yung end ng steepest ascent na path nyo. Tama? It makes sense, no? Kumbaga, if we go back to the, ano no, eto, parang sinasabi natin na nag-go tayo dito, tapos umabot tayo sa point na kung saan hindi na nag-i-increase siya. So, posible na nandito tayo. Kunwari, nagpa-path of steepest ascent tayo, paakyat. Tapos, umabot tayo sa point kung saan bumaba na tayo kasi na-reach na natin yung peak. Posible na yun yung nangyari. Okay? So, kunwari, tumaas tayo, tapos biglang bumaba. So, posible na, baka nasa peak na ako. Or, pwedeng nasa peak na ako. Or, kumbaga, merong other path that could give me a larger values. Kasi, di ba, take note again, ito, simple lang kasi ito, no? Kasi ang ginawa dito is, ay one peak lang siya. Pero, you can have something like, just to illustrate class, no? Pwede rin, ang nangyari kasi is, sorry. Pwede ang nangyari is something that looks like ganito, no? May transition. Pwede is meron tayong two peaks, no? So kunwari, ito yung first na peak. Kunwari, ito yung first na peak. So that's a peak. Tapos posible na meron pang second peak. Okay, so if this is your response, kunwari lang ito yung response surface, no? So posible na, and let me make this more clear, no? Pwedeng ganyan yung peaks, itsura ng peak. So, kunwari, ito yung path ng steepest ascent. Na-reach mo na yung peak. Pero pwedeng, if you head this direction, di malinaw yung drawing ko, no? So, kunwari, ganyan. So, ayan. Ganyan yung itsura ng peak, no? If you head this direction, you'll have the path of steepest ascent. So, ito yung first parang peak mo. Pero, if you move to the right of this peak, you'll actually have another peak dito sa area na to. So, pwedeng iba naman tong model na to. Okay? So, you'll actually have to do modeling again. So, pwedeng path of steepest ascent, 1. Tapos, you do it again, path of steepest ascent, 2. Tapos, kunwari dito, kung ito na yung actual peak niya, no matter where you go, whether you go this way, this way, this way, or this way, you won't find any model that will further increase the value because this is actually the final peak. And this is where magiging, in terms of statistical analysis, no, ito na yung pupunta na tayo sa yung tinatawag na CCD, which is the Central Composite Design. So later, I think because we are pressed for time now, no? So etong CCD, i-explain ko na in a future lesson. Pero parang ganito yung nangyayari, class. So nangyari is, we are now at a point wherein once the model has broken down, etong sa case na to, so we are here, no? Sabi natin na, sorry, nasaan na tayo? Nandito tayo, no? Itong 80.3 and 79.2. Sabi natin, nag-stop na ng pag-increase. So, we have hit a parang in a way, a peak of sorts. So, we can either pivot to another steepest ascent path, or pwedeng ang nangyari is we have actually reached the true local peak or true local maximum of that particular na region of analysis. Okay? So, once this happens is, syempre, kailangan yung gawin yung experiment ulit. So, that is what optimization is, no? You are constantly doing experiments to reach the optimized setting of a particular na process. Okay? So, the way, again, kaya importante itong steepest ascent because hindi nyo na kailangan i-test lahat. Ang kailangan nyo lang i-test is yung path na yung shortest path na magbibigay sa'yo ng fastest increase in the response variable. Okay? So dito sa case na to, since bumaba na siya, meaning you need to investigate this further, no? So in this particular case, pwedeng ang investigate mo is it's in between 85 and 90, no? So pwedeng ang gawin nyo is you can fit another model, no, in the region of 80 to 90. So pwedeng kunwari gawa tayo ng 80 to 90 tapos 170, no. So temperature naman of 170 to 180. And you do that experiment again. So kumbaga magiging 2 to the k experiment mo will look something like this. 80, this is now your low setting for time, 80. High setting for time is 90. Low setting for temperature is 170. High setting for temperature is 180. This is actually 180, no? Now, center point runs natin is 85 and 175. And you do the experiment again. And next meeting, i-discuss natin to, no? Kung paano natin siya i-solve. Pero ito, basically, this is saying na you do the 2 to the k 2 to the 2 factorial experiment with 5 center point runs, and we will try to fit another model dito. Tapos when we fit another model, if it gives us a new linear model, then we follow that model again. Tapos using this incrementing parang incremental increase in the time and temperature. Tapos tingnan natin ulit kung mag-increase siya ng yield. Okay? So later on, check natin what happens when wala na palang new path. So yun yung ituturo ko next time naman. So we end with this one. So ang assumption or ang scenario natin dito when we ended is we nag-breakdown yung model, hindi na tumataas. Therefore, ito na yung isang region wherein worthwhile na i-investigate natin. So gusto natin i-investigate to what actually happens kung nandito ka na. So because of that, we set up a new region for investigation, and the new region for investigation entails na meron tayong new center point, which in this case is since it falls in between 85 and 90, then worthwhile na yung new region of investigation natin is 85 and 175 kasi doon siya biglang tumigil, no, dito. Ito yung highest point niya, tapos biglang nung nag-increase to 90, parang bumaba siya. Okay? So kaya doon sa new region of investigation, center point runs natin is 85 and 175, and we do plus minus 5 again. Pwede namang hindi plus minus 5, no? This is up to you to decide, pero in this case, ang ginawa niya is plus minus 5 ulit. So 85 plus minus 5, that is the high point and the low point. And again, we do the 2 to the k. Okay? So later on, next meeting, we'll discuss this. Actually, we'll meet on Friday, no? And kasi konti na lang nandito sa Zoom session natin. Make an announcement. Meet tayo Friday to discuss about your project. Pwede sigurong I can finish this up. Tapos, sige, project discussion lang tayo on Friday. So, I'll set up the meeting. Tapos, siguro magsaset lang ko ng schedule kung kailan papasok yung certain groups, no? Siguro 15 minutes per group na lang yung gagawin ko. So, with that, wala na tayong time. So, meron bang questions, Kenneth and Martin? May questions kayo about the lesson? Wala naman? Okay. That's good. So, thank you for coming in today, and I'll see you on Friday. So, pakisabi na rin sa groupmates niyo na we'll meet on Friday para sa discussion ng ano. So what you need to prepare is yung working file niyo lang, yung kung ano yung RL na nakuha nyo tsaka ano yung parang final methodology na gagamitin nyo. Okay? So tapos through consultation i-refine natin yun kung ano yung pinaka-appropriate dapat na statistical tools na gagamitin natin. Okay? Okay, thank you for coming today and I'll see you on Friday.
Thank you, sir.
Okay.